So gas is one of the states that we talked about early on in the class. And there's a theory that goes behind this called kinetic molecular theory. And so kinetic molecular theory is a simplification of the gas behavior. And what it does is it makes the math very simple when we do that. And so let me state the ideas of kinetic molecular theory. So the first postulate is it's a collection, gases are a collection of particles in constant motion. And this is kind of a little bit of an assumption. Sometimes I like to put a little star on number 2. Because they're traveling so fast, there's no attractions or repulsions. Okay, the third postulate is there's lots of space between particles. Sometimes it's on the order of 10 to 100 diameters, where x is the diameter. And that's a lot of space. So the distance between the Earth and the Moon is like 32 Earth diameters. So that's just a tremendous amount. Another idea is that the speed of the particles increase with temperature. So basically on a hot day, I could just as easily say the oxygen molecules are moving faster. And actually in Chem 1A, we could calculate the speed. If we know temperature, we know the mass of the particles, we can calculate their speed. Class, we'll just say that temperature, and this little fish means proportional, is proportional to kinetic energy. And kinetic energy we define from physics as 1/2 mass times velocity squared. And so in a general sense, I can also state this, that lighter molecules travel faster at a given temp, such that the kinetic energy of one particle, let's just imagine hydrogen, the kinetic energy of hydrogen particles will be equal to the kinetic energy of oxygen molecules if I had oxygen and hydrogen gas particles together. If the hydrogen with a molar mass of about 2 grams per mole and oxygen having a molar mass of about 32 grams per mole, which is about 16 times more, then because the kinetic energy is equal to the mass times velocity squared, then the hydrogen would be going 4 times faster. Okay, so that's my just a couple postulates of kinetic molecular theory. I want to do a short review of gases from much earlier. We talked about gases at the beginning of the semester. Gases are compressible. They assume the shape of their container. They have low densities. So again, if there's 10 to 100 diameters between the particles, there's a lot of empty space. And by definition, they're going to have very low density. The mass to volume ratio goes way down. In fact, it's so much lower that for gases, the density is reported as grams per liter, which is different. Remember, for solid or liquid, the density was reported as grams per milliliter. And so the rationale for doing this is that, well, there's 1,000 milliliters in 1 liter, and gases are about 1,000 times less dense than water. For instance, air has a density of 1.3 grams per liter. If I was to use the other units, that would be equivalent to 0.0013 grams per milliliter. So by having a unit that is grams per liter, then it gives me ones place. And so that's nice to use.